Next speaker allows me to say two words that are not allowed on the MIT campus: Cambridge and Harvard. I said it because I'm not on US soil. I can say these two words. But Martin Forsythe, has both a degree from Cambridge and from Harvard, but he joined forces with some very bright MIT people, which is why he's on stage today. And the topic is the one that I've been alluding to and that Dimitris has been talking about, making really tremendous advances in machine learning to transform industry. So, Martin, stage is yours.
Well, I want to thank Trond and the STEX program and also BT for hosting us here and inviting Gamelyn to participate today. So Gamelyn is really two things as a startup company. One, we've been engaged in about a 3-year period of fundamental research in machine learning, close collaborations with researchers at the MIT Media Lab and at Stanford and some other world-renowned centers for machine learning. And then what we're doing to commercialize our breakthroughs in machine learning is trying to transform the way that data is consumed and integrated by an enterprise. So one of the themes that Dimitris and some of the other speakers have talked about today already is to make decisions in your organization, you need to consume data. And as the enterprise IT environment has fractured with the rise of self-service software and the cloud, we're consuming more and more feeds of information every day. And that information management is really getting decentralized. So what used to be controlled by the enterprise IT organization is now getting fractured out into the computers of all the business analysts using Salesforce IQ and Tableau, all of these tools that are living on desktop computers. So the future of the enterprise and consuming data is one where that management of data is going to need to be done by machines. It ceases to be manageable by humans and by the IT department. A lot of studies these days on sort of how an enterprise analytics project gets deployed quote that anywhere between 60 and 90% of the time in an analytics project is devoted to data preparation. It's not the fun part. And it's also just not the part that really drives value for a business. Cleaning up your data is not where you derive value. It's the decisions and the ROI that comes from that. So just a couple quick facts about Gamelyn in terms of where we are in the life cycle of a startup. We just raised a Series Seed. We also have significant government funding from this initial research in machine learning. We have offices in Boston and San Francisco. Currently our team is 10 PhD researchers and software developers, 2 business people. We're rapidly expanding. So the technology that we're working with is one that last year got on the cover of Science. It's called Bayesian program learning. Really what this is one of the technologies that Professor Dimitris was alluding to that can really beat deep learning. So depending on your background, you may or may not have heard about deep learning, but it's basically the standard approach that people take to doing machine learning today, where you try to extract everything about your decision-making process from the data itself. So you start with one model, can do computer recognition, it can recognize cats, or it can do machine translation, it can translate English into Russian, just from having looked at a bunch of data. It's extracting everything from the data, has no prior structure to it. What was discussed with Excelis is physics-based simulation. That lets you constrain your modeling space down a lot. So Bayesian program learning is a technology that aims to construct narrow physics-based models automatically. Basically have a program that can program itself. So the example here that got on the cover of Science was in the age-old problem of handwriting recognition. Though specifically, handwriting recognition in a limited data environment. So if I give you one example, one labeled example of a new character and tell you to recognize it from all of the future ones you see, that's a really hard problem for modern machine learning approaches that rely on seeing millions, billions of training examples to teach themselves their representation. Bayesian program learning was able to beat humans, that purple bar there, in addition to drastically beating deep learning approaches. So to conceptualize what this technology is, it sort of lives on a spectrum of modeling approaches between rules-based systems and deep learning systems. So rules-based approaches are great because they're understandable. You can go in and say, I have a rule that tells me a cat has 4 legs, it's got 2 ears, it's got whiskers. It's pretty easy to understand, but it's rigid. If the data, something about the world changes, it doesn't respond. And so these systems are brittle, they're expensive to maintain. That said, they do drive a lot of the intelligence tasks that businesses use to operate themselves today. So a lot of financial institutions still have rules-based systems running their decision-making. On the other side is deep learning, statistical machine learning approaches that try to derive everything from data. They're responsive, they're adaptive, but they're not very audible or understandable. You can't go in and say, these 100 million weights, little numbers in the model, what do they mean? What has it learned about the cats that it's learned to recognize? So Bayesian program learning lives somewhere in between those two, where the rules and the sort of high-level concepts are there, but you're also learning from data. So this gives you human-level accuracy. It gives you a way to transfer learning from one problem area to another and really compose your learning, which is, I think, one theme that in IT especially is going to be really important. So having told you a little bit about the technology that we're playing with, I just want to tell you about the market area that we're applying this technology in. So the data preparation and data integration market can be viewed at sort of three different levels. At the self-service level, there are new companies like Paxata and Trifacta that are trying to bring data preparation to the individual user so that it's easier to get your data from Excel, clean it all up, put it into Tableau, do your analysis there. More sort of enterprise data integration applications, Informatica, SAP, those tend to be sort of platforms that aim to connect into all of the databases in a given organization. And they give you a platform for doing your transformations on your data, but it doesn't do it automatically for you. At the larger scale, you have all the professional service organizations, the big four accounting firms and things like that, that will come in to an organization and really run a project for you. So to make an analogy here, those are sort of like chauffeurs. You can hire them, and they'll drive your application for you. The data integration platforms are a little bit more like limousines. They're a little bit more specialized to your application. They'll come and do one particular thing for you. And the self-service data prep softwares are like motorcycles. They're really lightweight, and they can just be deployed at a particular thing. We're aiming to build the self-driving car of data integration. So what I mean by that is a system that's going to live in the backbone of an enterprise. It's going to responsively adapt. It's going to drive itself and really replace this category 3 rather than just at the individual user level. So I just want to quickly take you through 2 use cases of some of our customers at the moment. But because data integration is a problem that occurs in all kinds of industries, please come and talk to me if you have a use case that's vastly divergent from these use cases, because we're really making a very horizontal move here. So one of our customers had a problem where they had a lot of data about products in different point-of-sale systems that they needed to aggregate together to make a virtual catalog. Of course, point-of-sale systems have lots of abbreviations. It's all hand-entered information. One person in one location will have a different convention than someone else. All kinds of mom-and-pop stores. And so the view of the data is something that's pretty easy for a human to read because we're good at understanding abbreviations. And we have a notion of what the products actually are. So it's very easy for a human, but very difficult for computers without machine learning. So we were able to take their various point-of-sale systems and drastically increase the percentage of their inventory that they were able to link up to their master catalog. And then the unlinkable merchandise was merchandise that they were able to add to their master catalog and increase their product diversity. So the effect for the customer here was that we were able to really increase the diversity of products that they were able to offer, increase their accuracy of matching. So this really reduced their customer churn, because if they said that they had a product on their virtual shelf, the customer went to buy it, turned out that it was a false match in their inventory system, customer gets pissed off, doesn't use the app again. In a slightly different use case, we have a Fortune 500 company working with us who, they're actually in telecom, and they have a problem where they have a lot of value-added resellers that are selling warranty contracts. And they have so many value-added resellers that they need to periodically go through and audit their partners. Of course, auditing your friends is a rather contentious task to do, so you need to be very careful with it. Could have serious legal repercussions if they falsely accuse their partners of committing fraud, if they are noticing some mismatches in the contracts. So they currently pay millions of dollars per year per audit to accounting firms to do this. It's a very time-intensive process for them because there's a lot of data comparisons. So fundamentally, the task that they're doing, the reseller has a list of their clients. They submit it to the OEM in the audit process. And then the OEM has their own internal list of the contracts that they're aware of. It's a giant matching problem, right? You have a list of 1,000 contracts here, a list of 1 million contracts here. You have to do all the point-wise comparisons. You have to do about 5 billion comparisons per audit, per reseller. You're doing this every couple months. It's a very large task. So we were able to take a pipeline of a process that looked like this, where you're going from data extraction to a professional services firm doing the matching. Then they, of course, want to do some human review to make sure everything is right. They don't really trust the offshore reviewer, so they do some more onshore review. And then they need to apply their business rules to the results, and then they can take action from there. We were able to replace that pipeline with something that looks more like this, where you go straight from data extraction to action in minutes. So the impact for them was that we were able to save them about $1.5 million on their audit spend. And really critically, we were able to make 2 times fewer errors for them, which really reduced their legal liability. So with that, I will conclude and take any questions if there are questions.